Good morning, dear students. In the last video, we have seen the list of the different factors which are affecting the equilibrium of the reaction, which is explained by the Le-Chatelier. And now here we will start with the first effect, that is effect of concentration change. What happens when the change in concentration takes place? So very first, as per the Le-Chatelier, when the concentration of any of the reactants and products in a reaction equilibrium is changed, concentration of any of the reactant or a product, if it is changed, the composition of the equilibrium mixture changes. So, if the reactant is changed, or we can say concentration, 1 mole is reacting or 2 mole if reacts are, if we add more reactant, then if the change in the concentration of reactant takes place, definitely the reaction mixture which is going to attain equilibrium also changes. And this is to be minimized, because if we keep on changing reactants, then the yield will not be according to our desire. So to minimize the effect of concentration changes, certain addition of the reactant or removal of the product is to be carried out. So Le-Chatelier's principle predicts that the concentration stress of an added reactant or added product is relieved by net reaction in the direction that consumes the added substance. So what is the prediction of the Le-Chatelier? That if the concentration stress of an added reactant is relieved by net reaction in the direction that consumes. So whatever you add, suppose if reactant is added and if that reactant added is consumed by the other reactant, then accordingly the reaction will start proceeding towards the forward, that is product will be given. But if the product is added, then it will be consumed by the reactant, and so the consumption will decide the direction of the reaction. On the contrary, if the concentration of a removed of, that means if reactant is removed, then the reaction direction replenishes the removed substance. That means if the reactant is removed, then its replenishes, product will try getting towards the backward and it will replenish. That means it will again change the amount of the reactant. The product will start reacting back and it will replenish. Replenish, that means it will re-change the position of the reactant from product to reactant. So let's have an example which will help us here. Here is the hydrogen gas and iodine gas which reacts to give hydrogen iodide gas. Now according to Le-Chatelier's principle, in case of addition of reactant or a product, a new equilibrium will be set up in which the concentration of the substance should be less than what was after the addition but more than what it was in the original mixture. So this thing is to be kept in mind, that in a case of addition of reactant or product, when the reaction is taking place, and if reactant is to be added or product is to be added, a new equilibrium will be set up. Now the reaction will be disturbed, so new equilibrium will be set up. In new equilibrium, the concentration of the substance would be less than what was after the addition. So after addition, what was the concentration? The reactions should be maintained in by such factors that it should be less, but it should be more than what was originally taken. So if originally 2 moles of reactants are taken, then after addition, few more amount of the reactant, the concentration should be more, because originally it was 2 moles. So now the concentration, if we add, then they will definitely increase from 2 moles to somewhat whatever we have added. But at the same time, it should be taken care that concentration of the substance should be less which was after the addition. So after the addition, you will have to take care of it. So let us see this thing in terms of QC. QC is again a equilibrium coefficient which can be calculated at any moment of the reaction. But Kc is the value which is calculated only at the equilibrium. And Qc and Kc, the calculation is products, multiplication of the product upon multiplication of the reactant. Now here if H2, it is a reactant. If H2 is added, then what happens? The reactant will start reacting a lot and it will be giving more and more product. That means reaction will be in the forward direction. And here as H2 is added, the value of QC will be less than Kc. And if H2 is removed, then the QC will be greater than Kc and the reaction will be in the backward direction. So this is the main thing which we have to keep in our mind. QC less than Kc, forward direction, product side, and QC greater than Kc, backward direction, it is reactant side. This is applied in Haber's process, that is manufacture of ammonia and manufacture of lime, that is calcium oxide. In Haber's process for manufacture of ammonia, nitrogen gas and hydrogen gas reacts to give ammonia. Now, commercially ammonia is prepared in a large amount because ammonia is the major component of a fertilizer industry for making the fertilizers. By one or the other means, in all the different types of fertilizers, the basic component is ammonia, so its yield should be more. And for the same, ammonia is removed from the reaction. Reactant, you can say here either reactant is added or product is removed. Right? So reaction will be forward. So ammonia is easily liquefying. Out of these three, all are gases. But out of this all three gaseous form, ammonia is very easily liquefying. So by the compression, it is liquefied and it is removed. It is by compression. So as soon as it is removed, the addition of the reactant is taking place. More the addition of reactant, more will be the product. So what happens here? Reactant added, QC will be less than Kc, reaction will be forward. Forward, that means product will be more. So on removing product, or we can say on adding reactant, QC will be less than Kc and the reaction will be in forward direction and the production of ammonia will be more. In manufacture of lime, the another process, that is the manufacturing of lime, calcium oxide from calcium carbonate. Calcium carbonate undergoes decomposition reaction, which you have learned even in 10th standard. Decomposition, thermal decomposition. If calcium carbonate is given heat, right, then it will decompose in calcium oxide and carbon dioxide. Now here, calcium oxide, carbon dioxide will be gaseous form, calcium oxide will be in the solid form. And we can easily understand here that gases will blow very fast. So here also removal of product will take place, and with it addition of reactant should be more. So more and more decomposition will take place for the production of calcium oxide. So CaCO3 decomposes to give calcium oxide and CO2. Where calcium oxide is widely used, why this process commercially is taking place at large? Because calcium oxide is widely used in the field of buildings, the great building, that is the construction work. So if one of the product is removed, then reaction will start in forward direction and thus the reaction yield will be more. Here carbon dioxide is constantly removed. As it is in the gaseous form, it blows up from the kiln. Kiln is the special type of oven, a very big oven. Or in Gujarati, if we say, it is a bhatto, right? Where it is produced, carbon dioxide is produced at very high temperature. And thus, with the removal of carbon dioxide, that is the product, QC decreases, then Kc, and thus the reaction moves in the forward direction and gives more and more product, that is calcium oxide. So this is the thing, that if the concentration changes, that means if the amount of the reactant or product changes, then there is a difference in the direction of the reaction, and accordingly the product is produced. Right? The another effect we will see in the next video. By the time, thank you.